Good day, my name is Sergio Augusto Helves Cortés and I'm going to present this work titled Fostering Remote Visualization Experiences in Two Different HPC Sites. The authors are César Bernal, Carlos Jaime Barrios, Benjamín Hernández, and me. This work is a collaboration between Supercomputación y Cálculo Científico YAJE from Colombia and Oak Ridge National Laboratory from the USA. The schedule for this presentation is as follows. First, a brief introduction followed by a description of the experience in each HPC site, then a discussion and an outline of future plans for the project. Introduction. Visualization of scientific data is crucial for scientific discovery. It allows the understanding and validation of the results of simulation experiments. Remote visualization is important for large-scale simulations because it allows infrastructure and resource access and helps avoid data movement. Also, it can help with collaborative interaction and decision-making. This work discusses two distinct approaches to remote visualization from two HPC centers attempting to signal commonality in their end goals while not focusing only on attempting generalization given the differences between them. The centers are SS3 YAJE from the initial in Spanish and the Oak Ridge Leadership Computing Facility. The first site, SS3, stands for Supercomputación y Cálculo Científico, an HPC center in YAJE, a public research university in Bucaramanga, Colombia. The center's flagship infrastructure is called YAJE and was conceived for GPU computing. The interaction with the infrastructure was originally limited to SSH remote access. The center identified some important user needs. The most demanded feature was some sort of visualization tool. This stems from the console-only interaction. Furthermore, users need tools that simplify simulation workloads. This notion is somewhat variable, since different users regard simplification in this context differently. But a common concept tends to arise. Users normally want tools that are similar to the ones used in their personal computers or workstations. Taking these concerns into account, the tool created, called YAJE, has some general design guidelines. Zero install approach to save the users from installing a custom client application. It will use BNC with virtual for performance. Because BNC is very common and widely adopted. It will use no BNC for the client component, so it will be web-based entirely. Finally, singularity containers will be used to isolate the different components and facilitate their deployment. The user interaction with the system will start with a Slurm script that will launch the containers, and after that the user will normally only interact with the browser. The use case for testing is a simulation code from the mechanical engineering department. They are using a simulation based on OpenFOAM for computational fluid dynamics applications. They wanted a tool that allowed them to change parameters in the simulation after visually checking the results from the previous running, a tool to fine-tune the simulation scenario. Also, they wanted to avoid downloading partial or non-definitive results to their machines on account of the slow network connection channels. The majority of users are connected from their homes. There were 2 test sets, or perhaps test batches, each with latency, bandwidth, and client FPS measurements. There were 2 test sets due to the phases of development and changing environment of the project. The last network segment conditions, which are similar to the ones the users are expected to have, are summarized in Table 1. The result report for the first test set can be looked up in the work of Bernal. The ample disparity shown between server and client FPS suggests connection-dependent behavior. Test sets aren't comparable between them. Changes in the university network impacted positively the performance. The connection use are within reasonable limits of what the average user connection will be in the city. For each variable, values of minimum, average, and maximum were taken. The results shows values within what is common with our connections. The table also shows data for a connection that became available in later stages of the project, Renata, which is a high-speed academic network connection independent from the university network. Results were even better, even coming close to the limits of the home connection. The frame rate test showed values within reasonable limits of usability. 60 FPS being optimal, but values of 40 FPS, of around 40 FPS will be reasonable. These results were confirmed qualitatively by the users of the OpenFOAM simulation. They considered the interaction adequate. More tests, especially human-computer interaction specific tests, are required, but the results obtained up to this point were deemed acceptable by the target users of the tool. Now we will talk about the second center, the Oak Ridge Leadership Computing Facility. They provide expertise in the form of guidance and support in the usage of the center resources through the Insight program. They also maintain close relationship with the teams and help develop custom solutions when standard ones are not feasible. Other important service the center provides is, of course, access to compute systems. These are state-of-the-art infrastructures, since the facility is one of the top HPC sites in the world. Even specialized visualization infrastructure is available. From interactions with the Insight teams, 3 important findings arise. The scale of data calls for solution for remote visualization. Mainly, support for exploratory visualization tasks. Remote visualization solutions capable of handling large datasets are required. Users are interested and actively prefer easy-to-use tools and interactive performance. It's important to note that these findings mirror the ones obtained in the first center, keeping differences of scale in mind, of course. From their experience with Insight teams and their expertise in HPC in general, the center designed Sight, a custom solution for interactive data analysis and remote visualization of atomistic simulations. It has a client-server architecture where the server manages the remote visualization resources and the client receives the visualization streams, basically sequences of encoded images, and provides UI for the users to see the results and interact with them. The use case in which they based the solution was an atomistic simulation of laser ablation on metals in the billion scale. with time steps of around 500 gigabytes. Originally, their analysis and visualization workflow involved moving a time step from the center to their facility, cutting the step into pieces, and reassemble, producing static images. It was time consuming and not very usable. Site allowed them to use visualization resources transparently while reducing almost entirely data transfers. Site was tested both qualitatively and quantitatively. In the first case, the publications of Dr. Sigilei's team showing Site being used successfully act as a reasonable proof. Quantitatively speaking, Site's ray tracing and data analysis performance results were presented in previous works. In this contribution, Site's remote visualization streaming performance is the focus. To evaluate the streaming performance, the frame server must be tested. Encoding and decoding speed is important to maintain latency low for smooth interaction. To conduct this evaluation, 3 modes of encoding decoding were tested. NVIDIA NVENC for H.264 for direct decoding in the browser. Then NVENC and on-the-fly MP4 wrapping for MSA decoding. The third mode was using Turbo JPEG for encoding. The results are presented in the table. NVENC was 3.6 times faster than Turbo JPEG in 1080p and 4.3 times faster in 4K. On the other hand, MSA decoding is faster than browser decoding in general. Now the discussion. The increase in computer power provides an opportunity to solve larger and more comprehensive problems and to efficiently handling data-intensive applications to remote visualization, as demonstrated by YAJE and Site. More available computer power should amount to more visualization power. In situ should be a factor to consider to attain this, as it aids in solving data movement problems associated with visualization and post-processing in general. More computing power increase user count and usage types, and with them, new expectations about usability. Finally, means of interaction that seem natural or common help improve user adoption and productivity. Also, it is important to understand resource limitations for users and for the site and work around them. The conclusions are: YAJE taught us about the importance of user experience in HPC adoption processes. Both centers are very different in terms of users, applications, and resources, yet share the same end goal: to provide support for scientists working on difficult problems. It's not what is available, but how can we make it useful to the researchers. Each center tackles a different part of the problem according to their strengths and limitations. Even though those solutions are not comparable, they show commonality in their conception. Future work. For YAJE, the possibility of an in-transit couple simulation should be analyzed. More use cases from different domains to obtain insight on possible general set of requirements. Usage of human-computer interaction metrics to evaluate the solutions. Improving efficiency in general. Now, the acknowledgments of the institutions that made this work possible. the Oak Ridge Leadership Computing Facility, and WIS. This is a selection of references used in this work. And thank you for your attention.